Okay, let's continue our class. Where were we? I forgot. Okay, so basically we are much faster using leaky relu. Okay, how about we change different one? There is another one, another relu. There is elu, okay, and gelu. Okay. Uh, okay, let's use. So the common one is relu, leaky relu, Swiss, elu, and tangent hyperbolic. This one. So all of this good for simplicity, but this one I think is for if we are. Oh, I think I have not shared the screen. Okay.
Yes, right.
Sorry. As usual, I always forgot. Okay. Okay. Where is it? Where is my? Okay, this one. So basically, the common one used in modeling is the relu, Ricky relu, Swiss elu, and tangent hyperbolic. But this one, the tangent hyperbolic, is normally used for classification function, and I don't know about Swiss. We can try. Elu, relu, and the leaky relu is for linear data. Okay, so we can try tangent hyperbolic whether it will converge or not. Okay, this one. So we change a little bit on this one using tangent hyperbolic. See what happened. Oops. Okay. And this one. Okay. Okay, we rerun the whole thing here. Oops. Oh, maybe small t. Complain or always complain. Okay. Let me see. Okay. Yeah. Small t. See what happened here. See? Doesn't converge. Very slow converge. And also the model is not good. Okay. So that's what happened in tangent hyperbolic. Okay. What happened if we have two value of y? So basically classification function with two, or maybe we can try the iris data. Okay, let's do it using iris data, but we need to change the code first. Okay, to neural network on iris data. So this iris data is in the what's that? In orange as well, generated from the I think it's in sklearn data set. I think. Let's. So we create this one. So basically, yeah, here. So the iris is from sklearn dataset. So we can use the built-in dataset in sklearn, and then we load the iris data here, and we have the this data and target. I think we have like 4 feature in iris data, and we split the data into 20% as test data, 80% for train data. On this one, we need to normalize the data, and then okay, interesting. See this? Okay. See this? We have 3 layers output. Why? We need 3 layers because iris data has 3 different category. Okay, let me show you. Iris data, iris flower classification. So in this iris classification function, we basically have 3 different category: iris setosa, iris versicolor, and iris virginica. Because we have 3 different classification, then we need the output layers, we need 3. Okay, because we have 3 classes. Okay, we have 4 input shape because we have 4 feature in the iris data. So we have 4 input shape, but the layer is 64 here. The front end layer is 64 nodes, the hidden layer 32, and 3 output. Okay, the epoch if 100. What else? So okay, let's play around with these things. Okay, I copy this one, put it here. Okay, run. Let's see what happened. The important thing we need to see is how it converge, how fast it converge, and then also basically it only plot the accuracy and the loss basically. Okay, so let's see. So this is the accuracy when it this one very close to 100% accurate. This is the training data, and this is the validation accuracy, and the loss. This is the training loss. Okay, it converts around here in this area here. Okay, so yeah, it's converts around this here. Okay, but when we see this one, it's quite the accuracy is quite conservative basically. Okay, because it tried to reach the convergence very slowly. Okay, we can always change this one, see what happened here. Okay, how about if we use so the activation function is softmax. How about we change softmax with other activation function, which is okay. Let's try change the softmax using, where is it? Oh, this one. Using tangent hyperbolic. Okay. Change activation. So my real suggestion is play around with the existing data and get some feeling how the algorithm perform for different data. Okay, see what happened here. I think we are in big trouble. Okay, we are in big trouble. It never converges. Okay, it never converges on this one. Okay, so loss function remain high, accuracy remain high, only high percent. So this is what happened if we change these things. Okay, so I will keep this into softmax and change ReLU into what's that? Tangent hyperbolic. Okay. 50. Okay, not much different. Okay, when we change the hidden function. Okay, now the other option we can play around with these things is to deal with nonlinearity in the data. So I will keep prelude here. How about we drop some of the node in the process? Okay, okay. What is the benefit for dropping nodes in a neural network? So we can drop the nodes known as dropout. So we can drop out. We can drop some of the node, okay, randomly. Okay, we can do some drop of node like this, like 30%. This one is 30%, or we can always use this one. Okay, why we need to do these things? To prevent overfitting. Okay, so basically the logic is very simple. To improve generalization, ensemble effect, and so on. But basically, the logic is like this. Okay, if we train someone, we don't want this someone is actually a neural network. If we train this neural network, neural network, we don't want neural network is to memorize the results. Okay, so overfitting basically memorizing the results. Okay, we don't want the neural network to memorizing the results. What we want is neural network to understand the results. So to be able to understand, we cheat. We basically cheating the training data by dropping some of the data. Okay, so we drop randomly on this one. We drop 30%. Randomly. Okay, by doing that, we basically make the algorithm reducing the ability of the algorithm to memorize the results. Okay, hoping the algorithm to be able to understand the results. Okay, so this is actually doing just that. So basically we cheat the algorithm, so the algorithm will not overfit. Overfit is memorizing the results. So hopefully it will understand. So I will do these things. So I will add this, copy, and put it here. Okay, see what happened. But for this one, I think we need to. I will keep the data as it is right now, but I drop like 30% here and 30% here. So basically, but to be able to make sure it will understand what we normally do, we actually increase the test size. So reducing the training data by increasing the test size, and then hopefully it will still understand. So, and then the way we test these things is basically by checking the accuracy, how the performance of the algorithm with reducing the test size, something like that. But at the moment, I will not reducing test size first, because we want to see the effect of dropping out the some of the nodes, like the 30%. Okay. Let me see. Okay, this is 50, 60, oops, 80, 100%. Okay, see this? it's much more, to be honest, for me, when we see this curve like this, it is much better than the previous one. Okay, because it converges quite good, and this one also converges quite good. It's different than the previous one, so we get a much better result like this. Now I will increase the test size. Okay, right now we have only 30%. What happened if we increase, or only 20%? So I will increase the test size to 40%. So 40% of the data will become test, and only what's that? 60% is the training data. The previous one is 80%. So from I don't know how many data in the iris. So basically 80%. Now let me make it more brutal. Oh well, okay, 40% is good enough to show something significant. After that, I will increase to 60% test data. See what happens. So we have to do something brutal like this. Okay. Okay, now. Wow. It has some difficulties. See this? We have difficulty here. Okay. So this is using test data. So we see the gap between test data and the training data. So when we increase too much the test data, so reducing the number of training data, we can see the gap here now. Okay, let me increase much more. How about I give this one like 40% test data? How about I give like what, 60% test data? So this one is much more brutal than that. So you need to play around with these things with your data to get some idea how the algorithm perform for your data basically. So you need to play around with these things, and also this one. Okay, this is we have several optimizer, the algorithm. Okay, this one Adam. We have several other algorithm. Let me see what happened with this one now. Okay, this is much. This is having difficulty to converge. So we have a lot of error here between the training and the validation. Okay. Okay, so let me see. So I will keep the training data 20%. See what happened with this one, the optimizer. Okay, let's check in Grok. What is the option for optimizer? Okay, and plus the important parameter of each optimizer. Okay, each and how to optimize the important parameter of the optimizer. Okay, let's see. So we have SGD. The parameter is learning rate. Oops, too fast. Adam is the one that we use. We have learning rate. We have beta 1, beta, and then the other one RMS, root mean square, RMS drop. Okay. So we can play around with this and see which one is best. Okay. Wow, there are so many optimizers here. So we can play around with this thing. I will pick randomly. Okay, now this is the one. Oh, interesting. Interesting. See this? Okay. XML with optimizer tuning for iris. So we can test several optimizer and see what happened with the iris. Okay. Interesting. This one interesting. Okay, let me copy paste this one. Okay, see what happened here. I don't know, maybe, I hope I'm not making any mistakes. Okay, change this one. Let, let me see. Oh, only the optimizer. Oh, to make it simpler, create the whole script to test for several optimizer for iris data and plot the accuracy and what's the other one? Accuracy and loss. Okay. So I don't have to think. Okay, so this is the one. So we can we still use iris data. 2% is used as test, and then wow, it will test for like 5 different algorithm, and then we prepare the storage for history and accuracy, and then this is the thing, and we have 30% dropout, random, and then history here, and then plot here. Okay, let's try it. Let's try this one. Oops. Okay, this is the one. Okay, let me check. Okay, this is correct. Copy, run. Okay, so on the next run I will try to test for like on this one, like iris data, all the data is basically numbers. It has values, numbers basically. I like to test for text data as well. So maybe later we can try the text data, okay, and see what happened. Okay. Okay. So it will test like 6 times, 5 times, 5 or 6, I forgot. So this is for Adam. Oh man. So I will test for the next batch. I will test. Okay, this is interesting. See this? So for accuracy, the other algorithm is much better than Adam actually. Interesting. So the rest, the other algorithm is much better than Adam. And then who's this one? So we have problem here. Okay. The rest we don't have problem. This one is on loss. Okay. So the accuracy is this one, but this one is loss, training loss. So the loss is the best one, I think. Oops, sorry. So this is okay, this one is okay, this one is much better. This is worse. This one. Adam is so, but oh, okay, you can see this one. At 25, Adam is only 0.4. This one, 25, is around 0.2. So this one is much better. This is the best one. Yeah, this is what? SGD. So SGD is the best one. So after we test this one, we realized that SGD is the best one because it's basically converse as around this one. Adam is not as Adam, and Adam W is close to the best one, SGD. Okay. Okay. Now I will ask Grok again what kind of data set we have with text data set. Okay, so we will play around with text. Okay, what are the text data set available in sklearn? Okay, because we know the okay, so basically we have two data sets. one, especially like this one. Okay, this one, 20 groups. This is 20,000 news group document partitioned into 20 different news group category, common use in text classification cluster, and the other one is router. This is news. Okay, for text classification, number of sample is about 800,000 news articles with 133 topics, multiple labels, and then this is very big, 2 gigabyte. How about this one? How big is this one? Few megabyte in raw form. Okay, so this is much more feasible for us to play around. This one is 2 gigabyte, forget it. Other data set is digital set, this is image. IMDb is for movie review, and we can customize text. So we will play around with this one. Okay, so I will ask Grok to generate the code to analyze 20 groups data sets here. Generate simple Python code to do simple classification on this one, 10 group data set. Okay, so we need to do some factorize this thing. Basically, we map the text into factor, into numbers basically. Okay, so we load 20. We have atheism. We limit only 2 groups. I don't know if you understand about newsgroup. Newsgroup is basically the chat group in the past. I was in this era as well, so I monitoring newsgroup in the past. So we have several newsgroup, and we have a lot of discussion in newsgroup, and then we can surprisingly, they actually archive some of the text in these news groups. I don't think we still have news group today. So, and then we train and test. Okay, so we have train. Oh, okay. This is the target, the label, and this is the text. Okay, the feature, actually the text, and this is the label of the text. Okay, so we have X train and Y. Oh, okay. This is training data. This is basically X and Y. So Y is the label. Okay, the target. So the X is the this one is train data, and the other one is the test data. Okay. See, the neural network is the same basically. Input layer 1000 features. Use of max. We have 3 classes, and the algorithm Adam, we can play around with the other algorithm SGD and the other algorithm as well, and see how it perform when it fit. Oh, okay. It doesn't. So basically only classification report XY class categories. Okay, let's see what happened here. Oh, okay, this is make prediction. Okay, okay, let's copy and run. Oops. Okay. So this one is text. This one is not numbers. So we are dealing with text, and then we need to make the text into vector to numbers by using this. What is it? This one. Okay. That's how we what's that? We convert text into numbers basically. So computer basically processing numbers. It doesn't processing text. In the LLM, sometimes we call it embedding. So this is basically embedding. Okay. So the precision is 80%. Recalls it 78%. So we can recall, and then the accuracy is about this one. Okay, so about 80% here. So using this method, 80% drop, we have 80%. How about we change into like we remove this one? What happened? Okay. And then we can play around with this one, the optimizer. We can change the optimizer into SGD and see what happened. Okay, still 80%, so still okay. How about we remove both? So this one is without dropping out the what's that, the nodes. No nodes drop out. Still 80%. So dropout is not necessary. What happen if we change this into SGD? Much better. Oops. Good for this one, but not good for the rest. So it's not good. This is okay, but not this two. Okay. So Adam is better. If you like, you can change the for the other uh, what's that? The other algorithm as well, optimizer. Well, we call it optimizer. Okay, let's try. So basically, this is the text. So we can deal with text. The important feature when we are dealing with text is this one, basically, to make the text into vector. Okay, and then it drops the English stop words here. Now this is the problem. I don't know whether it can drop the Indonesian stop words. Let me check. Indonesian. I don't know. Or Malay or Indonesia. Okay. This one may that's broke. It may complain. Okay. Okay. Or less or none. Okay. So there's no Indonesian stopwords here. So it's unlike the I think list is we need to upload a list of stopwords. Okay. So then we can like add Indonesian stopwords if you like. So but for English is fine like this English. Okay, so basically we have the source code for analyzing text like this. Okay, now for more complex data, we can always ask Grok to do these things. Now, what I like to show you. After having the data, what we normally do is we try to predict different data. Okay, but for this one, we normally have two different data file. One file is for test, one file is for training, and we split the. We have the whole data and we split. One is for training data, the rest is for testing. But we can set our mindset that the test data is actually for forecasting. So if we have two different data, we can do forecasting on that on our model. Okay, now to make it more explicit, we can ask Grok to have, for example, this is an example. Let me see if I can. Okay, create CSV file with x1, x2, and y. So basically we have two different features and y, but I will try to create with function y is equal to 2 x1 plus 4 x2 with noise. Okay. Okay. So I will be doing this thing for 2 times. Okay. I asked for creating a CSV file. It gave me the source code. Okay, no problem. Okay, so it will create the SC file, and then okay, I will copy this one Okay. So my planning is, oh, I will reload this one much better. So my plan is we will create two files. Okay, one is training data, one is for prediction. So we are trying to forecast two different files. Okay, so this is the files. So this is training data CSV. Training data CSV, and then we will generate another file which is for so we have after when we run this program, we will have training data CSV. Okay, and then next time the second run I will but this is 1000, make it like 500. Okay, or 300. So we have only 300 data for training. Well, okay, make it 1000, fine. But for the prediction, we'll make like small numbers. Okay, so we have two different files. One is training data, and the other one is for prediction. And we will read those two files, and then we will use the script to read the training data to get the model, and using the model we like to compare the the other file. So I have not set the name yet, so this is the training data. Okay, so it based on this equation, 2 times x1 plus 4 times x2 plus noise. Okay, now I want to set the model for predict data. So we set 100. Maybe I make it into 4.01 plus noise. And then this is not training data. I will make it into predict data. So I have two files. One is training data, one is predict data. Okay. Okay. So we have two files basically, training data and predict data. Now I want to create a script, Python, script to get the model, to get the y equal a times x1 plus b times x2 model from training data CSV file, and do prediction based on the model, do y prediction based on the model from the name predict CSV. Okay, predict data dot CSV file. Okay, so we are not generating the data anymore. So basically we so the data is from a file, CSV file. We have two files, training data CSV and predict data CSV. Okay, but we tell the grok the model should be something like this. Oh, okay, and plot or predict or calculate calculate the accuracy of the model to predict data CSV file. Okay. It seems like a linear regression task where training data is this one. Yeah, you're right. And script will load the predict data for valuation. Okay. Okay, so basically we read the training data and do linear regression with 2xy, okay, no intercept, okay, and then fit the linear regression. Oh, this one using linear regression, man. I need to change a little bit then. Use neural network. Okay. Sorry, I want to use neural network. I don't want to use linear regression. Okay. Come on, come on. Okay. Wow, this one is crazy. Okay, see this? Single dense layer without activation linear model. So it forced me to use linear model. Basically, this is linear because no activation function. Okay. Let me change a little bit the problem. Okay, cancel. Okay, this one is okay for a start. So basically we have it loads the training data, loads the predict data. So we have X train and Y, and X test, Y test, and then scale the features. Okay, and then do neural network. This is not neural network basically. This is it use neural network algorithm subroutine, but it is a linear subroutine. So you adapt mean square error, fit the data, and extract the model and get the A and B and print it. Print the A and B. Calculate the error, print. That's it. Okay, let me see what happened. Copy. So okay. So we will get the data from these two files, okay, and run. this one is quite high. Well, this one is depending on the wow. Okay, okay. This is the model. So my model, the first model, I think +3 or something. Let me see. Let me see. Where is it? Where did I put it? Wow. I should put it in different. Oh, I'm not saving the original. Okay, I should put it in the. Oh, this one. 2 and 4. The original one is 2 and 4. But it gets like. Where is it? Here. 1 and 1.5. Okay, and it has bias here. Okay, so basically it fails. Let me see if I can force the code to use like more complex neural network. But if it is complex neural network, then we cannot get the A and B here. For complex neural network, we cannot get it. We can calculate Y precisely, but we cannot get this one. Okay. Let me see if I can change this one to function of okay, use 3 layers or 4 layers neural. Wow, okay, 3 layers neural network with activation function. Okay, maybe activation ReLU. Okay, let me see. Let us see what happened with the. I like to see the convergence. Oh, not this one. This one is only the accuracy. I like to see the accuracy, how accurate the software can predict Y. The model should have 3 layer neural network predicting Y based on X1 and X2. So this one, and then it will iterate up to 100 times. See if maybe I need to change a little bit. Plot the accuracy and we need to plot the accuracy. Plot history of error and accuracy. Okay. this one. Read that. I don't want. No, no, no. To read training. Oh, sorry. Training data CSV. Fit the model to this one. Okay. Use trillion neural network with classification function. Do prediction based on current model to predict data CSV and calculate the accuracy model of the predict data CSV, plot history and accuracy. Okay. I want to read the data file. Okay, read the data. Okay, let me see. So basically it will read CSV file. Okay. File not found. Yeah, okay. And I need to read the predict data. Okay, file, and put the predict data here, and then do the prediction here. So this is the important subroutine. Do prediction here based on the this data. So basically we compare this data, the predict data, with this data, training data. Okay, and then we plot the history here. Sorry, where is the history? This one, history as training loss and validation loss. Let me see if I can copy the whole thing here. Okay, now I copy this one, put it here. Okay. Okay. 15, 16. It's very slow convergence. Said, oh, okay, this convergence is like 600 something, and the error going down to like 3. No plot. I'm looking for the plot. There is a plot. I'm asking for plotting. Oh, still running. Still running. Because I'm asking for to plot the this thing. Oh, okay, this is the one. Okay, it converges around here. Okay, the training R square is about 1. The validation is, well, not much different. So basically it converges quite fast around this one, around 10. Okay. Okay, now how about we so to play around with these things, the other thing is we can ask with the grok whether there is a data set with very nonlinear data set in the SK learn. Okay? And then we can play around with the nonlinear data set, and then we can get some feeling on the what kind of algorithm we need to use to deal with very non-linear data set. This one is linear data set. This is fine, and then I'm not really changing the what's that? Change the value so much. Only tweak little bit, so it converts like at around here, like 15 or something. So it's about the same, the loss. The error is about the same here. So it reads the convergence around here. Okay. So around 18 less than 20 is converge. Okay. Now the most difficult one is when we deal with non-linear data set. Okay. What what is the non-linear data set available on sklearn? Okay. Oh, okay. So Iris is what? Okay, I didn't realize that. Oh, okay. So Iris is considered to be nonlinear. What else? Okay. Digit data set. Oh, this is image. Image for handwritten. Okay. This is for image recognition with nonlinear patterns, because this is I think it's handwritten, and we need to classify the handwritten, and because this is digits, so the text is from 0 to 9, 0 1 2 3 4 5 6 to 9. Okay. Okay, this may be good to play with. Okay. So I will ask. So we have close to 2,000 digits. The features, so we have 10 class from 0 to 9. Okay. So we have 10 class, but we have so many pictures here. Okay, so what we are going to do is ask Grok create Python source code to get the model for digits dataset from sklearn. Okay, and test test one test one of the what's that, the data on the model. Okay, plot the image and print the what's that, the value. Okay, because the digit is from 1 to 9, 0 to 9, 0 1 2 3 4 5 6 7 8 9. I want the script to plot the image and print the value of that particular image, of the image. Okay. Okay, let's see what happened here. So I asked for creating the Python source code to get the model from digit dataset. Okay, so this is the load digit data set here. Okay, so we have digit data set here, 8 by 8 pixel value. Wow, my wife is calling me. Ya, masih ngajar. Halo. Halo. Okay. No, no sound. Okay, so load the digit data set and scalar and split the data with 20% for test, 80% for training, and we have 10 class here. So the class is here, this one 10. We can change this into this one. Oh, okay, and then compile, train the data set, and okay, okay. Now this one, okay, what this one is for? This one, this is the interesting one. Okay, now select single test sample. Okay, this is so after we get the accuracy and select single test sample, and this one is 0. Okay, and then we want the script to predict what is the 0, and also I want to plot, okay, the 0. Okay, now let's try to run this thing. Okay, okay, now it predicts 6. This is the actual image. The label is 6. We predict 6. Okay, so this is the image value here. So this is 8 by 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. This one X 8, and down is 8. Okay, the label, the true Y is the 6, and we predict 6, so it's correct. Okay, now what happens if we change the this one? This is 0. How about, because we have like 1000 sample, how about 1001? Okay, this is 1001. I don't know what number is this. See what happened. 1001. Out of bound. Oh, we have only 300. Okay, sorry. So we have 300. I thought it's 1000. Okay, so we have only 300. So we change into 201. So the label is 9, predicted 9. So we can test any image if you like, but basically we get the accuracy is this one, 100% accurate. Okay, so we can play around with these things, using this model, and then we can change the optimizer using this setup. We can see the accuracy is 100%. So we can, so to deal with your data, we can play around with the model, finding which one is the best one to fit your data. Okay. Okay. My wife is calling me. I have to pick her up in the mall. See? Okay, if you have any, let me see if you have any questions here. Let me see. Oh, Franciscus, you want to ask the last day, time for filling out the quiz. Okay, basically, basically the last day is when Professor Wiranto have to submit the final grade to the academic. So I think you have like one month plus or 1 or 2 months from now to do my quiz. But those who already get like 80 something is fine. 70 is fine also, but that's like, I don't know. That's based, Professor Wiranto will decide what is the final mark. But basically 80 is fine. 70 you pass, but not, I think not the highest mark. 50 something, 60, I think you need to do more exam. That's it. So the deadline is based on Professor Wiranto. So I will update the mark to you guys and Professor Wiranto. Hopefully every week. I don't know. Maybe every week or 2 weeks. I post to you and Professor Wiranto, and then he will decide so he will combine his mark to my mark, and that's the final mark. How to combine, he decide, not me. So I am only the additional lecture to you. The actual lecture is Professor Wiranto. Any more questions? No more questions. Okay. So this is, I think, my last day for teaching. If you have any questions, feel free to send me email. So I will put my email in the chat. So you can send me email, or you can send me email to this one. So I have several emails. Feel free to send me email if you have any questions. And my advice is use Grok as many times as you like, because it will help you a lot. Okay, so I will close my class now. All the best to you. Hopefully you can do your journal paper as soon as possible. Otherwise you will be in trouble in finishing your master degree. Okay, thank you. Good luck and all the best to you. Thank you.
Okay,
Thank you,
thank
sir.
you, Sigma.
Okay, bye bye.
Thank you, sir.
Thank you.